Today, I'm speaking with Rick Mitukiewicz, Vice President of RIA CONNECT, who will be discussing some of the products and services that RIA CONNECT offers. Your main product line is PC board terminal blocks. Please talk about the changes you see in the marketplace.
The terminal blocks have been around for many, many years, since probably like the 1950s. There are two distinct terminal blocks, electrical and electronic. We as a company specialize on the electronic side, which are terminal blocks on PC boards. And some of the markets that we sell into are the HVAC, heating, ventilation, air conditioning, the security market, fire control panels, access controls. We also sell into like sprinkler companies, and again, the controls behind this, instrumentation, industrial controls. What's been happening over the years, a couple of the changes have included, one, smaller connectors, which means higher density center lines for the connectors. Everyone's making their products smaller and smaller. These terminal blocks have to fit in tighter spaces, so the challenge is to make smaller terminal blocks. But with that said, there's also been an evolution for customers' requirements to bring more and more power to a PC board. So that's actually evolved into higher current and higher voltage terminal blocks in addition to the smaller center lines. And some of the terminal blocks now can get up to about 125 amps to a PC board, which is quite significant when you're talking about an electronic application. Some of the other areas that terminal blocks have evolved into are what they call through-hole reflow applications. In the past, terminal blocks were always going through wave solder baths, and in today's electronic environment, most of the PC boards are what they call surface mount. So there's no holes on the board, and they go through these high-temperature reflow ovens. Now, the challenge there for terminal blocks is to have the plastic material be able to handle that heat. Unfortunately, terminal blocks don't adapt well with surface mount components because of the fact a lot of terminal blocks are screw type. So when an installer is tightening down the screw, he's applying a lot of torque. And with a surface mount type terminal block, what happens is the pads on the bottom of the terminal block could easily rip away from the PC board. So through-hole technology is still a better mechanical solution. But again, with that, the challenge there is these PC boards are going through high-temperature reflow, and we're talking anywhere from 245 up to 275 degrees C. So we've been developing more and more terminal blocks with higher temperature characteristics. Probably the biggest change, and it's a very slow, methodical change, is one from a screw-type terminal block to a spring-type. And what that basically gives you is labor savings out in the field. So instead of an installer having to tighten down the screw, and sometimes these PC boards might have 100 different positions, which mean 100 different screws. Now, us and many of our competitors have gone to spring clamp technology. So instead of having to tighten down the screw, sometimes you just have to poke a wire in, or worst case, just you press a lever and insert a wire. We do have a special patent on some spring clamp terminal blocks which allow us to have a lever in the open position, so all an installer has to do is insert a wire and snap the lever closed. It is a slow migration. Probably the biggest downside on spring clamps is the fact that many installers like to insert 2 wires per position, which is not the best solution for a spring clamp product. So that's why there is some resistance, but most applications out in the field, you have 1 wire per position, and the spring clamp technology has really taken hold, and I see that increasing as we move forward over the next few and 5 to 10 years.
Thank you so much, Rick. That was extremely informative. For more information on RIA CONNECT, please visit their website at www.riaconnect.com. Or, for ordering information, please visit www.onlinecomponents.com.